go! Alright, welcome back from spring break. We're doing section 10.2 today. Talking about conic sections, parabolas. We have two major learning targets. We're going to write the standard or conic form equation for a parabola when you're given the key features of the parabola. We're also going to rewrite an equation for a parabola in standard or conic form, and then identify the key features from the equation. I'm going to talk a little bit about parabolas and conic sections, and then we'll get into the maths. Here we go. Conic sections are what you get when you take two cones called napped cones, where they're just two cones that are sitting on top of each other, so their points are touching, and you slice them. So if you slice it parallel to one of the circles on the end, you get a circle. If you slice it perpendicular to the circles, you get what's called a hyperbola. If you slice it at an angle, you get an ellipse, and an angle that goes through both sides. And if you slice that at an angle like this, well, it's just through one side, you get a parabola. And that's what we are talking about today, parabolas. The other sections will be on ellipses, circles, and hyperbolas. Here we go. Let's talk a little bit about parabolas. Parabolas have some key features. They have an axis of symmetry, which we will just call the axis. They have a vertex. Now, you all have learned about the axis of symmetry and the vertex in Algebra 1 and Algebra 2. Today, we are going to be looking at what are called the focus, and the directrix. Those are two new key features for the parabola. Why do we care about the focus? Which in this picture, this is our focus, and this is our directrix. These are important because when you use parabolas in contextual situations, such as absorbing sunlight in a solar panel, or using a flashlight or a headlamp in a car to shoot light forward, the focus basically is what everything reflects out of or reflects to. If you have vectors that are shooting in perpendicular to the directrix, they will all reflect toward the focus perfectly. And similarly, if you have light or something emitting out of the focus, it will reflect perpendicular to the directrix. So it's good for concentrating light beams and that sort of thing, which is why we care about parabolas. So let's get to the maths of it. We're going to talk about the conic or standard equations for these parabolas. So let me dry this off a little bit. There we go, much better. All right, let's pick a color that will show up. So, we have talked about the general form before for a quadratic. The y equals ax squared plus bx plus c. You are all familiar with that. There's also vertex form and intercept form. Standard slash conic form, standard slash conic form takes two forms. Whether we want a, oh, that's my doggy Emma, sorry. Whether we want one with a vertical axis, so one that's going like this, that has an equation of x minus h squared equals 4p times y minus k, where the vertex is at h comma k, p is not equal to 0, and p is the distance from vertex to focus or vertex to directrix. If p is negative, you will get, so negative p, your graph is going to be pointing downward. Positive p, it's pointing upward. Now, if this is your vertex and this is your focus, this distance is p, and this distance is p to the directrix. So this 4p, this number multiplying by y minus whatever, that 4 times number, that number there, p, tells you how far from the vertex to the focus and the vertex to the directrix. Moving on to a horizontal axis. If we want something with a horizontal axis that looks like this, this is for positive p, this is y minus k squared equals 4p times x minus h. Basically, you just switch the x minus h and the y minus k, they switch spots, so now the y part is getting squared. So here, once again, p is the distance from the vertex to the directrix, but this time the directrix is a vertical line, and the distance p to the focus from the vertex. All right. Now, if p is negative, the graph is going to go that way. Very well. You can see this on the lesson slides. It goes into a little more detail. Let's move on to some examples. This should make more sense. Make sure you have this written down though. That's important information for when we do our examples. So, example time. The first 2 examples will help you with the first 3 problems on the assignment. Nice and clean, nice and plain. There we go. Let's go back to a fun color. Pink shows up pretty well. So example 1. Example 1. We want the standard or conic form equation for a parabola with a vertex at 2, 1. So the vertex is at 2, 1, and the focus is at 2, 4. So I like to just draw a little picture of this. So we go 1, 2, 1, 2, 1, 2, 3, 4, 2, 4. We have a vertex there. Just a sketch of the graph. I don't know exactly where those points on the curve are. And the focus is here. So this tells us for our equation that we have a vertical axis, because we also want the equation for the axis and the directrix. So the axis is going to cut right through the vertex. So we can answer that already. The axis is the equation for the line, the vertical line going straight up and down through it, through the vertex and the focus, which is going to be at x equals 2. Now we need to find where the directrix is, or the equation. Let's look at the equation. The equation is going to be x minus h, where h is the x number of the vertex, so x minus 2 squared equals 4p, we'll fill in the 4p in a moment, times y minus the y number of the vertex. The y number of the vertex is 1, so it's y minus 1. Now p, remember, is the distance from the vertex to the focus, or the vertex to the directrix. So we say 1 to 4, that's p equals 3. So p equals 3 means 4p equals 12. So we can erase the 4p and write in 12. So the equation is x minus 2 squared equals 12 times y minus 1. This is the conic or standard form equation. We have the axis of x equals 2. Now we need to find the directrix. The directrix is the line that is perpendicular to the axis and is the same distance as the vertex to the focus, but on the other side. So I'm going to go vertex to focus is 3. So I'm going to go 3 down from the vertex to find the directrix. So we're at 1. I need to go 1, 2, 3. The directrix is this line right here at y equals 2. Sorry, negative 2. I goofed. It's a negative 2, because we are 3 below the vertex. The focus and the vertex is always in the middle of the focus and the directrix. So here is our equation, the axis and the directrix. Let's go to the next problem. Example 2. Here we have the information of a focus. Focus is at 4, negative 3, and the directrix is at x equals 8. So I'm going to sketch a little graph of this. We go 4 and 8 for our x's. So 1, 2, 3, 4, 5, 6, 7, 8. And negative 3 for my y. 1, 2, 3, negative 3. So that's my focus at 4, negative 3, right there. And then the directrix is right here. In order to write the equation, I need to know where the vertex is, because that's my h and k. I also need to know what direction the graph is going. Here we have a vertical axis, so the x part was squared. Here our directrix is vertical, which means our axis is horizontal, which means our parabola is going to be going to the side, which means the y part must be squared. So we know that the vertex is going to lie on the axis of symmetry, or just the axis, and it's equidistant between the focus and the directrix. The focus is at 4, the directrix is at 8. That means the vertex is right in the middle at 6, negative 3. So vertex is at 6, negative 3, and the axis is at y equals negative 3. Now we need to say what direction does it go. The parabola will always open up to the focus. So the focus is in the middle of the parabola. So think about like a headlamp, or a car's lights, or a flashlight. The bulb is inside and it curves around to reflect out. The focus is the bulb. So we get a graph that looks like this. To write the equation, it's going to be y plus 3 squared, because the y is a negative and y minus negative 3 is y plus 3, equals 4p times x minus 6, because 6 is the x number on the vertex. Now, 4p, well, p is the distance from the focus to the vertex or the focus to the directrix. But in this case, it's going negative, so here p equals negative 2 to have a distance of 2, but in the opposite direction. So 4p is going to be negative 8. So negative 8. Now, something I forgot to point out earlier. Silly me. Every point on this parabola, this is what makes parabolas, this is another thing that makes parabolas beautiful. Every point, boop, like that point there on the parabola, this distance from the focus to the point is equal to the distance from the point to the directrix. So every single point is the same distance from the focus as it is from the directrix. These distances are obviously different, but this distance and this distance will be the same. This distance and that distance will be the same. All right, moving on to the next examples. So, let's just do a little bit of recapping. You are going to be given information about the focus, the vertex, the axis, or that directrix, and you will need to find the equation and the rest of the information about it. What you need to remember is that the vertex is in between the focus and the directrix. The directrix is perpendicular to the axis. So if your directrix is y equals, then your parabola is going up or down. If your directrix is x equals, in other words, a vertical line, then your parabola is going to the side. The parabola always opens up and contains the focus inside of it, so the directrix is outside the parabola. It's not inside the part of the U, it's on the outside of the U. And if the graph is going up or if it's going to the right, the p-value or the 4p is positive. If the graph is going to the left or the graph is going down, the p-value will be negative, so the 4p will be negative. Lastly, when you're writing your equation, if it's up or down, the x is squared, it's left or right, the y is squared, and it's always x minus x number squared, and it's the x number of the vertex equals 4p times y minus the y number of the vertex, or y minus the y number of the vertex squared equals 4p times x minus the x number of the vertex. The x number of the vertex always goes with the x. The y number of the vertex always goes with the y. Alright, let's move on to the next learning target. So here, this is a little bit more complicated. Algebraically, we are going to be given an equation that's not in the standard conic form, and we're going to have to use our maths brains to rewrite it in that form, which involves everybody's favorite, completing the square. And remember, completing the square is really not that bad. You just need to practice it a little bit. Excuse me while I drink some water. I'm feeling a little bit parched. So go ahead and copy down the example. Sorry I didn't write it on the... Hopefully you have your notes with you. The notes from the lesson. All right. Pink seems to be doing well. So this is example 3. we have y equals 1/3 x squared plus 2x plus 4. We want to write this in the standard conic form. We also want to find the vertex, the focus, the directrix, and the axis. First thing we are going to do is I want to make it a regular x squared, not a 1/3 x squared. Because remember the goal is going to be x something squared equals something times y something. Right? Right. So I need to get the regular x all by itself. Here I have 1/3 x squared. I want x squared. So I'm going to make that 1/3 into a 1 by multiplying everything by 3, because 3 times 1/3 is 1. And because this is an equation, we can do that. So the first thing we want to do is make the squared term just 1 squared term. Not 1/3, not 4 squared, 1 squared. So I'm going to multiply by 3 here. I'm going to multiply by 3 on that side. And I get 3y equals x squared plus 6x plus 12. Wonderful. So now what I'm going to do is I'm going to isolate the x's, or the terms that are being squared. If I had y squared, I'd isolate the y's. Here I have x squared, so I'm going to isolate the x's. I'm going to do that by subtracting 12 on each side. Minus 12 minus 12. So I have 3y minus 12 equals x squared plus 6x. Now that I have this, I want to complete the square. In other words, I want to make this into a perfect square. I can't just be like, poofity poofity, it's a square. I need to do some maths. Oh, there goes my shirt sleeve. Let's just roll that up a bit. I thought I had that buttoned. All right. So if you'll remember, we used to do this as x squared plus 6x. We'd go plus blank minus blank. Right, well, we fill in what's in the blank to make that a perfect square, and we can add and subtract the same number. But because we have an equation, instead of adding and subtracting the same number, what we're going to do is we're going to add the same number to each side of the equation. So it's still finding that special number, but in this case, whatever that special number is that completes the square, it's going to just add to both sides of the equal sign of the equation, keeping the equation still equal. So, in order to find this, to find the perfect square, the value that makes it a perfect square, remember, we take this b value, we divide it by 2, so 6 divided by 2 is 3. We square the 3, and that gives us 9. So we add 9 to each side. Now, after doing that, x squared plus 6x plus 9 happens to be a perfect square. If you do this properly, every time it'll turn out to be x plus or minus. If this was a minus sign, that would be a minus sign. That's a plus sign, so it's a plus sign. It's always going to be this number, half of that. Half of the b value, so x plus 3 squared. And then here I have 3y minus 3, because negative 12 plus 9 is negative 3. We are almost where we want to be, right? We have x plus 3 squared. But here we have 3y minus 3. I want something times y something. So what I have to do is I have to factor out the coefficient on the y. I look at this, I say the coefficient on the y is a 3. So what I'm going to do is I'm going to rewrite this as 3 times, and I'm going to divide each thing by 3 to find out what it is, to factor it out. So that gives me y, because 3 divided by 3 is 1, 1y, minus 3 divided by 3 is 1. So here we have 3 times y minus 1 equals x plus 3 squared. That's our answer. So 3 times y minus 1. We have our equation, but we need the vertex, the directrix, the focus, and the axis. So let's go ahead and find those. Easiest of all is finding the vertex and the axis. The vertex is x numbers opposite of the x, so -3. Y numbers opposite of the y, so -3, +1. So vertex is -3, 1. The axis, if it is opening up, if the x is squared, it's x equals the x number. If it's horizontal, it's y equals the y number on the vertex. So here it's x equals -3. Now we need to find the focus and the directrix. In order to do that, we need to know the p-value. So we look and we say, well, 4p is 3, because this is normally where the 4p goes. But in case instead of a 4p, the number is 3, so I need to find out what the p-value is. In order to do that, I solve the equation 4p equals that number. So 4p equals 3, I divide by 4, divide by 4, divide by 4. We get p equals 3/4. That's not our vertex or our focus or our directrix. That is the distance from the vertex to the focus, or the vertex to the directrix. So now looking at this graph, the graph is going to open up. How do we know it's opening up? You say it to yourself, and then I'll tell you. We know it's opening up because that 3 is positive, and x is squared. So, in order to find the focus, let's do that one. The focus, it's lying on the axis, so it's at -3, comma, and then it's going to be p above the vertex. Because it's opening up, the focus is going to be inside. So the graph essentially looks like this. -3, comma 1, graph is opening up that way. Focus is here, directrix is there. So -3, comma 1 plus p. So 1 plus 3/4 is 1.75, or 7/4. And remember, if the decimal stops as a 1.75, you can use a decimal. If it doesn't, say, let's say if it was sevenths or ninths or something of that sort, just write the fraction. All right, and that is the vertex with the y value adding the p. So the directrix is on the other side, and this is an equation, it's a line. It's a horizontal line in this case. So the horizontal line is going to be y equals, and it's going to be the y value of 1 from the vertex minus the p value. So -3/4, 1 minus 3/4 is 1/4. So we have finished. We have the equation, the vertex, the axis, the focus, and the directrix. This is like problems 4 and 5 on your assignment. We are going to go ahead and continue with one more example, and that'll be it. All right, example 4. Let me erase this. Erase, erase. There it goes. Goodbye. Goodbye. You're now stuck to a microfiber cloth. And then dry it up. Dry it up. Here we go. Very nice, very nice. That's my dog, Emma. I think she... Oh, nope, she's barking at me. She's like, what is that ridiculous accent you're talking in? Isn't that right, Emma Bear? I think she said that's right. Okay. 0 equals... Sorry, this is example 4. 0 equals -1/2 y squared minus y plus 1/2 minus x. There we go. Take another drink of water while you write that down. Okay, let's try a new fun color like orange. So the first thing that we want to do is we want to make the squared term a 1 squared term. Here we have a negative 1/2 y squared. We want just a 1y squared. So what we're going to do, multiply everything by -2. Because if I multiply by -2, that turns that into a +1. You could also add it over and multiply everything by a +2. That would work as well. But let's multiply this side by a -2 and this side by a -2. There's more than one way to approach a certain problem. So here I get 0 equals y squared plus 2y, because a negative times a negative is a positive, minus 1, because -2 times +1/2 is -1, and then plus 2x. There we go. Perfect. The squared term is a 1 squared term, 1y squared. Now what we want to do is we want to isolate the variables that are getting squared. In this case, the y is getting squared. So I want to get the y's all by themselves. So to do this, I need to get rid of the -1, and I need to get rid of the plus 2x. So I'm going to add 1, minus 2x, minus 2x. So we have -2x plus 1 equals y squared plus 2y. Wonderful! The y squared and the y are all alone, and the x and the other number are by themselves as well. Now what we want to do is we want to complete that square, because in this case, because the y is squared, the goal is to have y something squared equals 4p x something. So here we got to get the y all by itself. So we're like, square, complete the square. So -2x plus 1 plus blank equals y squared plus 2y plus blank. What number goes there to make that the perfect square? Well, we take this coefficient on the linear term, the b value, we divide it by 2, we get a 1, we square the 1, and that's our magic number that we add to each side. So, here we go. I get -2x plus 2. -2x plus 2 equals y squared plus 2y plus 1 is the same as y plus 1 squared. Remember your factoring, you could actually factor this if you want, or it's always y